Object interaction is a fundamental part of many games. Some use it as their sole mechanic, and others as only a small part of their gameplay. It can have wide-reaching effects from picking up an item to changing the environment or game world. But the fundamentals of object interaction systems stay the same across games. And in this video, I'll be showing you how to add your own modular object interaction system into your own game. And if you stay until the end, I'll show you something extra you can add to really elevate your game's object systems even further. So in order to actually start with this, in Godot, open up your editor and create two scripts, an interaction area and interaction trigger. Starting with interaction area, the first thing we need to do is extend it from area 3D and then give it a class name, in this case, interaction area. After that, it's quite simple. What we need to do is add a trigger, which says the interaction has been triggered, and the trigger function itself. Everything else we're going to be relying on the inbuilt area 3D for the area. The interaction trigger, we once again want to be extending area 3D and giving it a class name. In this case, interaction trigger. Following that, we want to add in our interaction areas. So these are the areas that we're going to be colliding with as the game goes on, and therefore we know what to trigger as we're moving around in the game world. We're also going to add in an initiator node, in this case a node 3D, because we're creating this for a 3D game, and I'll touch on later on what that's for. Moving on, we need to create a function to capture the areas that we're entering, and the same for exiting. A particular note is that we are only interested in area 3Ds that are actually interaction areas. Other than that, we don't want them. And this allows us to add them to that list and monitor them accordingly. And in order for these to work, we need to add in a link into our own signals for the area 3D to then run these functions. Nice and straightforward. And then the important bit is the trigger interaction. In this case, when a user tries to trigger that interaction, we need to check that we have any interaction areas in scope, and if so, pick one. In this case, I've always defaulted to the last one, but you don't have to do it that way if you feel a different scheme makes more sense for your game. Now that we have our modular interaction code created, the next step is to integrate it into our game. In this case, we can add an interaction trigger to our player, as well as giving it a collision shape 3D. In this case, I've put a shape in front of the player, so I'm only able to interact with objects that are in front of me. You may choose to do differently. But adding that trigger itself won't do anything unless we have a way to actually initiate the trigger code. So in this example, I just created a very simple player inputs checker, which is purely dedicated to searching for an interact event and then emitting a signal, which I've hooked up to the interaction trigger. As you can see here, interaction pressed, and then interaction trigger.trigger. For those of you that don't know, in order to actually set up these controls, you can go to project settings, go to input map. You can then add in your action type and assign a key to it. In my level, what I've done is I've created a fire, added an interaction area, also a collision shape, and then I've set up a CPU particles 3D, which I've just set to be invisible. Set the interaction area so that it triggers the show command or show function on the CPU particles 3D when it's interacted with. So showing this, what we have is our game. I can move up, press R, which is the trigger that I put, and we have a fire starting. But the next step makes it fairly interesting. So you may remember that earlier I said that we were adding an initiator node to our trigger, and I didn't explain why. Now it's time for me to explain why. So by having an initiator, what I can do is I can still initiate this fire just as I did before, but I can also cause an additional effect relating to the player. In this case, I've simply hooked it up to player's particle effect, but I could do more complex interactions, such as setting up a player to animate, to, for example, do an animation to set the fire, to open a chest, a door. I can also use this to add an item to an inventory, or target somewhere the player is with a attack or an effect. So in terms of how we actually do this in code, it's quite straightforward. All I've done is added in a script to our fire object that I've now made the target of the collision area. So particularly I've added a separate one. And all it does is find the target and then, in this case, find the child, which is sparkle explosion on the player, and then set the emitting field to true. Similarly, I could play an animation, etc. And this relies on the fact that we're passing in this target field from the interaction area and the interaction trigger, which we looked at earlier. And specifically, what this is on the player, I've assigned this to be the initial node itself, so the player node, which then gives me access to all of the things underneath it. At this point, you've had all the information that you need in order to actually create multiple different effects on your game in a modular way. And you can do this just by adding more and more things into the signals from the interaction area. But there's something else that we can do to make the game more palatable and understandable for your players, and we'll touch on that now. For an object interaction system to avoid frustrating your players, it needs to be obvious what is and is not interactable. There are a few ways of doing this. One, you could add a small sparkle to every interactable object, or alternatively, if you wanted a subtler approach that was still readable, what you can do is add an indicator to items when you get close to them they're available. As you can see here, when I go close to an interactable object, I get a symbol at the top saying press R. I move away, that moves it away. This is a very useful aspect to do and can be very easy to add in code. So let's walk through that now. So back in Godot in our interaction trigger script, the first thing we need to do is to add some new signals. In this case, we're adding in the available interaction added and available interaction removed signals, each of which take the interaction area that has been added or removed, respectively. All we then need to do is at respective points call this code. So in this case, I'll add the available interaction added to the area entered event and the removed to the area exited. And that's it for the code changes that we need to make for the interaction trigger. What we do need to do beyond that is in our player, add in a canvas layer. The canvas layer is the effectively 2D representation of a screen that you can then work within. In this case, I've added an interaction highlighter, just my control node that I'll be using in a moment, a color rect, and a label. In this case, all of this contain the letter R that I'm using for indicating that you should press R. Obviously, a more complex system would allow you to change key bindings, etc. That's outside the scope of this particular tutorial. From that, I've then created an interaction highlighter script. Within that, I'm going to extend control, as it's a control node, and then I'm going to start properly on the code itself. So to begin with, what I want to do is add a count variable. So this node is effectively going to keep track of how many areas we potentially could interact with. And when this value is 0, then we're not able to interact with any areas. If it's more than that, then we can. Let's do that. I'm going to add in a function to increase the number of interactions in an area, as well as add in a function that I'll flesh out in a moment to actually determine whether or not to show or hide the label as and when needed. Similarly, I'll need a decrease, and then I'll need to actually flesh out my calculate display state function as well, which is quite simple. It's visible if the count of interactions that we could interact with is greater than 0. And then just to flesh this out a little bit, we'll also call that on ready so that it's correct when we start the game. From there, we just need to assign these functions. So here we can see I've got an interaction trigger, and I've already assigned the available interaction added, available interaction removed to the increase and decrease of the interaction highlighter respectively. And that's then all that we need to correctly have our indicator display as we get close to our interactionable area. So in this video, you've learned the importance of object interaction systems, as well as how to add one to your game. But isn't it just as important for your characters to be able to speak and converse? Check out this video where we dive into exactly how to do that.